Hi there. My name is T, and I'm one of the people behind Mighty Maths. And I just want to say welcome to the website. Firstly, let me warn you, I am filming in real time, so if I do stumble or stutter, forgive me. And also, I have got some notes that I might be using. So, yeah. So basically, yeah, if you're watching this video, you could be a leader or a lecturer in a profession. When I'm saying a leader, I mean somebody that's in a practitioner or practice. Right, let's try that. Hi there. Welcome to Mighty Maths. Firstly, I should warn you this is a real-time video, so if I do stumble or stutter, forgive me. And secondly, I have some notes, so forgive me if my eye contact isn't always on the laptop. But yeah, okay. Basically, this video is aimed at leaders and lecturers in the profession right now. So when I say a leader, that's somebody that's school-based and practicing and could be a head, a deputy, a middle leader, a senior leader, or a subject coordinator, or it could be a maths specialist. And if you're a lecturer, this is kind of ideally aimed at those that are in initial teacher training. Could be for mathematical practitioners, but ideally that's what the video is aimed at. Of course, anybody's welcome to watch it. So, about me. So right now I am a primary school teacher, well, trainee, and I have a mathematics specialism. Probably by the time this video goes live, I'll be qualified. But yeah, the main aim of Mighty Maths and this whole website, you know, the lesson plans that are on here, PowerPoints, SmartNote presentations, is basically to just show other people a different side of maths and I guess to some degree making it fun and kinesthetic, but also about understanding different ways to kind of access algorithms, such as the one on the board, and I'll come on to that in a second. So right now, I'm sure everybody's aware, trainee, NQT, head, whatever, you know, our profession is going through some drastic changes, some for the better, some for the worse, opinions will differ, and, you know, now more than ever before, you know, the raising standards and you know the bar that it takes to get into this profession and to be in this profession, they're exceptionally high. For example, if you want to start, you need a 2-1 generally in your degree, or a first or a master's. You should have A levels relating to that subject, and you know you need your A to C in English and Maths and Science for GCSE. So you know there's a lot of academia that is required to get into the profession firstly. And you know, if you want to do a specialist PGCE or become a specialist teacher, then ideally all of those points need to be linked or geared towards your subject that you're training. So for someone like me that is a maths specialist, I should have a maths degree, I should have A levels in math, and I should have a GCSE in mathematics, and I have none of the above. My degree is in management and marketing. I didn't do A levels, I did a BTEC. And my GCSE, well, I got a D the first time round. But, you know, I've managed to become a mathematics teacher, and it's kind of that alternative route that I have into mathematics, more so the functional side of it, that makes me what I would like to say is a good mathematics teacher. You know, for example, with my GCSEs, I had a D at first. And that was because I struggled with maths. I had dyslexia at that time. Didn't know that until I began my teacher training. And I also, unconfirmed, but have dyscalculia. Again, didn't know that until teacher training. And now, how that's actually helped me is when I'm in the classroom and I've got my children that are lower abilities, the emerging ones, my SEN students, my EL students, I have a lot of empathy to where they're coming from. They may not understand the traditional algorithm, so for me, I kind of remember what it was like to be in their position, and I think, what did I need at that age, or what did I need at that time to understand what was going on and to achieve the same outcome as everybody else. My degree was in management and marketing. Now, although there was a lot of mathematics in it, it wasn't explicit and it wasn't direct. But what came out of it was a lot of functional skills, a lot of money handling, a lot of data processing. And so what happens is when I teach maths, I use that experience, I convert a lot of things into decimals, which I'll come on to in a second, and that kind of puts me in a very, very strong and fluid position. And I think one of the last points I wanted to kind of cover before I go on to this is the fact that, with the profession and standards being so high, what's quite interesting specifically about mathematics is it calls for a high academic level in the sense that you have to have, if you want a bursary, you should have first, 2-1, etc. You should have an A level in the field, or your degree should be related in that field, and have those GCSEs. And generally, the kind of people that I've come across who are on the same training as me, or even on different courses, all achieve their GCSEs, their A levels, and the degree at the first hurdle. So, in terms of struggling with mathematics, it's not a concept that they have. So, I would never discredit another teacher at the end of the day, because that's what we're here to do, is to get everybody, all of our pupils, up to the same standard, or continually raising their standards at the same amount. But when it comes to children struggling, it's very hard for them to kind of understand why they're struggling, and it's very hard for them to see the flip side of the coin. Whereas, again, not to sound conceited in any way, shape, or form, but because I've seen, I know how it feels to struggle deeply with a subject, and I also know how it feels to kind of excel with a subject now. It's like I can see both sides of the coin, so therefore when I have my struggling students, I kind of have a lot of empathy or a lot of methods that might be able to help them. And when I have the higher ability ones, I've also got the skills now to stretch them and kind of push them further. And Mighty Maths is about kind of breaking those bridges, so there's some kind of fluidness between the two, and possibly using it as a practitioner, a leading practitioner, to develop your awareness of how maths could be taught, and obviously raise achievement in mathematics. So as a really kind of cliche example for this, what I want to do is just go over this fraction. This is something anybody should, well, not anybody, but a lot of teachers should be able to do, hopefully. But in its simplest form, or traditional algorithm, if you want, we've got 1/2 plus a quarter, and we're going to add them together and get the answer. Now, I wouldn't have been able to have done this at school at all, and it obviously it's not a one-step question in the sense of it's just adding numbers together. There's different steps. Firstly, we have to make sure we've got the same denominators to be able to add it together. And then once you've done that, we've then got to remember not to add our denominators together, and then we've got to add a new. So it's a lot for children to do in terms of the lower ability ones. And also as well, if your child might have short-term memory or short-term memory issues, or issues around that kind of development, then it also makes it a lot harder in terms of remembering each and every step and making sure we do it okay. So, it might seem quite simple on the offset as someone who's in their 20s or 30s or in the career, because we've had to train to do that. But for children, this is or could be something that's quite complicated. So, traditionally, what we would do is obviously, as I said, make sure the denominators are the same, so we times our fraction by 2, so that becomes 2 over 4 plus 1 over 4. And then obviously, now we've done that, we can add them together. So 2 over 4 plus 1 over 4, we're going to add our denominators. Well, we don't actually add them, you just keep them together, so that's still 4. And then we add our numerators together, so that is 3. And obviously the answer is 3 over 4. One thing that I might have just done, which is actually incorrect or not really good practice, is I changed my terminology to the equation, and that can throw off some children. So obviously if you say 2 over 4 or 1 over 4, you should keep using that throughout your lesson, because if I say 1/2 then 2 over 4, it will throw off some children. Now moving on, so that's obviously how we might teach, how to add fractions, and that's something that not everyone might get. This is something that I struggle with actually off the top of my head. However, again, this is where my experience comes in handy now, in the sense of I've dealt with a lot of money. And what I would do is I actually wouldn't look at the fraction as a fraction, I convert it into decimals. So automatically I know that my 1/2 becomes 0.5 if we go to 2 decimal places. And I know that I've got 0.25. So 0.50 and 0.25. So let's add those together. So even if you want to just get rid of the decimal places, we've got 50 add 25. We know that's 75. And obviously it's a decimal, so I know that now 50 or 0.50 plus 0.25 equals 0.75. So that's how I would be able to access this question. And then what I would do is obviously I know out of 100, 75 is 3/4. And that's just how I would access that sum. And for those that might be struggling, that's how I would possibly change it to get them into the kind of concept of what we're doing. And then once they've actually grasped the concept of what we're doing, I would go back to the original algorithm so be able to do it. But that's the whole point. It's about finding different ways, different tricks, and different methods for each and every individual pupil in your class. And another thing as well that I would also do is I would firstly keep everything color coded. On the whiteboard right now, what you see is a lot of black. And again, for somebody that might have learning difficulties, special educational needs, it is a lot of numbers, there's a lot of confusion, and it can throw them off in terms of where to guide their eyes and also the process of what we've done. So what I would do, or what you will find throughout Mighty Maths, is that a lot of it is color coded. So the original sum was 1 over 2 plus 4, and then obviously that equals. So even if you didn't even know what we was doing, you would see somehow that there is a relationship. And again, if I changed all of these, which I would in my class, you would still see another relationship. So you would see green for one colour, black for another colour, and you do red for the answers as an example. So it's just about keeping it consistent, and that's what is apparent from a lot of the Mighty Maths stuff in terms of lesson plans, PowerPoint presentations and worksheets. And obviously it's about building up the confidence, especially in the lower abilities, just to make sure that they can get that footing that everybody else might have. So yeah, that's pretty much it. Hope that kind of gives you an insight into kind of why I've done Mighty Maths, and possibly, you know, I don't think it's a massive contribution to the educational system, and I don't intend to become the new Nicky Morgan, but it's just about making sure that there's some level of awareness for anybody at any stage in their career, whether they're an NQT or a classroom teacher with 25 years of practice, just be able to see the different sides to maths and making it accessible for all. So yeah, that's pretty much it. I hope you enjoyed that video, and yeah, well, enjoy.